Welcome everyone to the study guide review video for the 7th grade Unit 2 test. Let's dive in. Number 1, which graph represents a proportional relationship? Okay, this should be, definitely the easiest question on the test, hopefully one we know right away. So when we think about proportional relationships in graph form, they look like lines that go through 0, 0. Okay, so we just have to figure out which of these. There's only one correct answer. Is a line that goes through 0, 0. Okay, if we look at A, that's a line, but it does not go through 0, 0. So it's not A. B is not a line. C is a line that, again, does not go through 0, 0. And D is our right answer. It's a line that goes through 0, 0. Okay, all that is. Okay, question 2. This graph shows the cost in dollars, C, of W pounds of strawberries. The relationship is proportional. Select all of the true statements. So here we have the graph on the x-axis. We have W pounds of strawberries. So on the x-axis down here, or like the w-axis, we're talking about the pounds of strawberries. And we're talking about the cost money on the y-axis, or like the c-axis here. Okay, we're going to want to start right off the bat, find the constant of proportionality. And we can do that by taking the y-coordinate and dividing by the x-coordinate. Okay, so my constant of proportionality, k, is going to be 16.25 divided by 5. Okay, and when we divide that, we're going to get 3.25. That's the number for the constant of proportionality. And then if we think about that in the context, we were taking $16.25. We were taking, this was the y, so this was my cost. Okay, so we were taking, right, this y is from the y-axis, which has to do with cost, so that's the money. And then 5 here represented the 5 pounds of strawberries. So that means it's $3.25 per pound of strawberries. Okay, so if we look for that, that's going to be the second option. 1 pound of strawberries costs $3.25. Okay, so that's right. And the first one is incorrect. 3.25 pounds of strawberries cost $1. So if we're not sure about that, again, you just want to try to take a second to pause and reason through this, right? If we think about this number that they gave us, this number says 5 pounds of strawberries cost $16.25. So the cost for 1 pound is going to be, the cost for 1 pound is more than $1. So definitely the cost of 3 pounds here is going to be more than $1. Okay, so you just want to pay attention when you're doing y divided by x to the units that you're talking about. So it's in this case, the dollar sign, since that's associated with my y-axis, divided by my strawberries, the x-axis. Okay, so yes, that one, no, this one. Then we can keep going. So then if it's a constant of proportionality, we know that if we have 4 pounds of strawberries cost $13, when we do the same thing, when we would do $13 divided by 4, if this were a constant of proportionality, or if this was true, right, and on this proportional relationship, then we would get the same number, 3.25. Okay, and that's correct. If you do 13 divided by 4, you get 3.25, so that's also going to be true. Then I can do the same thing here. For 10 pounds of strawberries costs $32, so I'm going to do 32 divided by 10, but that's going to be 3.2 period, 3 and 2/10, not 3.25. So that's not going to be the same. It's not the exact constant of proportionality. And the same thing is true here. We have the point 310 is on the graph. Again, I would take the y-coordinate and divide by my x-coordinate. 10 divided by 3 is 3.3 repeating, or 3 1/3. we're not getting the same constant of proportionality, so that one is not correct. Okay, so we have those two true answers. And again, this is just something we struggled with a little bit with reading questions. Select all of the true statements means there's going to be more than one correct answer. If it says which graph, right, that's not plural, it means there's only one. Cool. Okay, question 3. Abdullah walked to school at a constant speed. He walked 1 mile in 15 minutes. Which two equations represents the relationship between the amount of time in minutes t that it took him to ride a distance of d miles? Circle one of the 4 multiple choice options. Alrighty, so there are 2 equations that we can write to represent this proportional relationship. Okay, and as we see in the options, one of them is going to be in like t equals. So that means we're given the distance and we want to figure out, okay, given the distance, what do we do to distance to find the time? And then the other version is if we're given the time, what do we do to that to find the distance? Okay, so as a starting off point, this is a proportional relationship. Walking at a constant speed, 1 mile in 15 minutes. So we shouldn't have addition. Like right off the bat, nope, not A, not B. Okay, we're not dealing with addition here. This is a proportional relationship. We're only multiplying or dividing. Okay, so, but between C and D, it can be kind of tricky. So what I want to do is I want to use what I was given. I was told that 1 mile took 15 minutes. In this 1 mile, that is my distance. That is D. Okay, and then my 15 minutes, that's my time, T. So if I know my time, and I know that in this case that's 15, and then I want to figure out what my distance is, and I know in this case it's 1, I'm thinking like, okay, 1 equals what times 15? What times 15 is 1? That's going to be the reciprocal of 15, which is 1/15. So then if we're doing it in this relationship, this direction, if I know the time, which is the bigger number, it's 15, I multiply by 1/15, or I divide by 15, but it's going to be multiplying by 1/15 here, and that's going to give me the distance. So we're going to see that equation here. Okay, and then if I want to do this in the other direction, which I should check. Okay, what if I'm given my distance, and I know here my distance is 1 mile, and I'm trying to figure out what the time is. Well, I know here my time is 15 minutes. Okay, then I'm thinking, well, what do I have to do to 1 to get to 15? I multiply by 15. So in this situation, I'm taking my distance, I multiply by 15, and that tells me how many minutes it took. Okay, and again, that is then this equation. So C is the right answer here. We should see the relationship between these equations here, 1/15 and 15. These are reciprocals. They multiply to give us 1. And whenever we're trying to write 2 different equations for the same proportional relationship, we just are switching the variables around, like which we're considering the independent variable. We have this reciprocal relationship. Cool. Okay. Next, we're looking at these graphs. The 2 lines represent the distance 2 runners ran in a race. Which runner ran more slowly? Okay, so here we're saying distance per time. Okay, the constant of proportionality here is giving me the distance you ran in a period of time. So as was the case, like faster, when we're looking at these graphs, the steeper line here is going to be the faster runner. Okay, because that means that they've gone in a shorter amount of time, they have more distance. Okay, so the steeper line is the faster runner. So based on this, the question is, which is the slower runner? So that's going to be person F. Okay, that's going to be person F. I would accept you just saying, right, like that the steeper line, or really in this case, the less steep line, means the person is running more slowly, because it means that the constant of proportionality, which is the speed per minute here, is less. Okay, so if it's less steep, if we take the y divided by the x, we're getting a smaller number, and that's the speed here. Okay, but mainly I would accept if you say the line is less steep, okay, and that means it's going more slowly. Okay, so that's a fast one. Okay, question 5. The table shows the weight of 100 blueberries at a market. Complete the table so there is a proportional relationship between the number of blueberries and their weight. Okay, so we have this table, and I need to find the constant of proportionality. So in this situation, I'm thinking of my blueberries like my x and my weight like the y. To find the constant of proportionality, right, we're trying to figure out 100 times what is 60 hundredths, or 0.60. So to figure that out, we can do y divided by x. We can do 0.60 divided by 100. And that is going to be 6 thousandths, 0.006. Okay, so it's a small number, but that's the answer. So we're multiplying by 6 thousandths. So then complete the table, we're going to take the number of berries, right, and we're going to multiply by 6 thousandths, and we will get 0.36 or 36 hundredth grams, and 2.42 4/10 grams. Okay, so this is a relationship. We can just sort of do that without thinking about the context. But now we're trying to make sense of what this real world meaning is. Okay, so how did we get this? If we look at this a little bit more carefully, for the constant of proportionality, we took 60 hundredths kilograms and we divided by 100 blueberries. Okay, so when we're doing that division, we're getting like a unit rate or a constant of proportionality that one blueberry weighs 0.006 kilograms. So we wouldn't really generally measure blueberries in kilograms. Kilograms is a large measurement. It's 1,000 grams. We normally measure like really heavy things in kilograms. And one blueberry is very small, which is why this is a very small number. Okay, but if we're thinking about, hundreds and thousands of blueberries, then it starts to make sense to measure it in kilograms. Okay, but so this number, 0.006, that's the constant of proportionality. And the real world meaning is that each blueberry weighs that amount of kilograms. 6 thousandths of kilogram. Okay, so we'd have to explain that, including the unit. Then we're going to write an equation for the proportional relationship where B represents the number of blueberries and weight represents the weight in kilograms. So if we see here, so now I was using X and Y before, but now we're going to use these. This is B and this is W. To find the weight, which is like the Y or the second column, to find the weight, I take the number of blueberries, just like I did here, right? I took the number of blueberries, I multiplied by my constant of proportionality, and that gave me the weight. So out here, I'm just going to take the number of blueberries, B, and multiply by my constant of proportionality, 0.006 or 6 thousandths of a kilogram. Okay, and that's it. You could put the multiply symbol if you want. It's a little confusing with the 6 and the b here, or not. Either way, that's the equation. All right, and then finally we're going to use the equation you wrote. So I'm going to use this equation. I'm going to rewrite it to find the weight of 250 raspberries at the market. Oh, that should be blueberries. Always make a typo, I feel like. The question on the actual test is about raspberries, not blueberries. Okay, so to do this, here's my weight. I need to figure out the weight, and I know that I have 250 blueberries. So what I'm doing here is I'm going to substitute in 250 for b for my number of blueberries, and then just do exactly what the equation tells me to do and do exactly what I did in the table. I multiplied 250, the number of blueberries, times my 6 thousandths of a kilogram, and that's going to give me the answer. So that should be 1.5 kilograms. So that's my answer. Again, I'm doing just what I did in the table, but I'm writing it in my equation form. So I'm taking my blueberries, multiplying by the constant of proportionality, and it gives me the weight. Awesome. Question 6, the equation P equals 2.22x relates the mass in pounds P to the mass in kilograms X. Is there a proportional relationship between P and X? Show or explain your thinking. Okay, I'm looking at this equation, and I see that X is being multiplied by a number. There's no exponents, there's no addition, there's no subtraction. All we're doing is multiplying X by a number. So yes, this is a proportional relationship. Yes, X is being multiplied by a constant of proportionality to get P. Okay, that's it. That's enough. It's a proportional relationship, right? I guess I could say it's in the form y equals k times x, which is the general form for a proportional relationship, where k is the constant of proportionality. Cool. And then our final question, a recipe for tortillas uses 5 cups of flour for every 4 cups of water. The line represents the relationship between the amount of flour and the amount of water needed for this recipe. The point 1, 1.25 is on the line. Explain how you can tell there is a proportional relationship between the cups of water and cups of flour in this scenario. Okay, so this question, straightforward. I'm looking at a graph. How do I know it's a proportional relationship? The graph of this scenario is a straight line that goes through 0, 0. Then we're going to write an equation that represents the graph line. For F, use the number of cups of flour, and W for the number of cups of water. Okay, so if I look at this, flour, F here, that's on my y-axis, and water is here on the x-axis. So when I think of my equation, it's always going to be like y is equal to the constant of proportionality times x. So in this case, it's going to be F is equal to the constant of proportionality times W. And then I need to find what the constant of proportionality is. But they give it to me. They give me this point, which is 1, 1.25. So to find the constant of proportionality, I can divide 1.25 divided by 1, but that's just going to be 1.25. We know that the constant of proportionality is the y-coordinate when x is 1. So that's it. It's the constant of proportionality. And what is it saying, right? It's saying we're talking about this relationship between cups of flour and cups of water. So 1 here matches with my cups of water because that's my x-coordinate. And 1.25 matches here with my cups of flour. So what is it saying? It's saying when I'm making this recipe for tortillas, I'm going to combine 1 cup of water for each, I'm going to combine 1.25 cups of flour for each 1 cup of water. Okay, there we go. When making tortillas, the recipe calls for adding 1.25 cups of flour, Again, it's saying my Y, my cups of flour, for each cup of water. Cool. That's all it is. All right, you got this. I think it's a very doable test. Good job watching the video. Good luck tomorrow.